Hi, guys. So we are continuing our solving equations problems. In the classroom attached, you'll find these notes. So I'm going to go through them with you. If you can print them, great. Or if you want to just write on top of them, that's fine too, as a Word document. Whatever helps you understand them the best. So if maybe even just take a piece of notebook paper, because I think you have to really write this stuff to understand what's going on. So yesterday we were talking about how to take these verbal phrases and put them into symbols. We did the Khan Academy, you did a homework. Please check the answers for the homework. So here's the thing. I post the answers so that you can check yourself, not so that you can just copy them. If you just copy the answers to the homework and turn it in, it doesn't get you anywhere. It's just a complete waste of your time. I don't care if your homework is wrong. I just want you to make sure you try it and check it, because it's the only way to know if you're understanding it. If you just take my answers, copy them, and turn that in, you just wasted all of your time. Do the homework, turn it in, and check it so that you can see if you understand or not. I can't help you otherwise, and you can't help yourself. And when it comes to a test or quiz, it's going to be a problem. So, we're just at that point where if you want to, skirt by and just turn in the homeworks, it's only 2 points. So you're really not doing much for yourself by getting those points, because you're going to lose so many points when the quiz comes around. So you've got to make sure you understand and you don't just submit copied answers, because it really doesn't help you at all. Anyway, so here we go. So now we're going to be solving these equations, these word problems that have some meaning to them. So even though I think we laughed in class 8 anyway, about your favorite word problems are sometimes like, if George has 60 watermelons and John has 3 times as many, blah, blah. It's always kind of funny that, why is anyone carrying around 60 watermelons? So I'm sure that's going to come up every once in a while, but we're going to start with fairly simple problems, and then this will continue to build over the next week or two. We don't have class Wednesday or Thursday, so there won't be anything new. And on Friday, we'll add another word problem, and we'll just keep adding until we get to the week before Thanksgiving, where we will have a quiz and then probably do something fun maybe the day before Thanksgiving. Okay, so here we go. Number 1. If Henry has 3 more than twice as many toys as George, and the total number of toys they have is 48, find the number of toys each has. So I'm going to do my notes in blue so you can kind of see the difference. Okay, with all of these problems, we're going to have 2, sometimes 3 unknowns. So right now, what we have as unknowns is we have Henry's toys. Oh my goodness gracious. And we have George's toys. I'm really sorry. I will be better at this. For some reason, I can't seem to write and think at the same time. So I'm going to come up with some kind of algebraic way to represent how many toys Henry has and how many toys George has. Now, this seems like a waste, right? Why don't we just think about it? Why don't we think, if the total number of toys they have is 48, well then, pardon me, maybe Henry has 1 and George has 47. Maybe Henry has 2 and George has 46. It would take us so long to go through all of those possibilities. We want to use algebra to guide us so we don't have to go through all of the possibilities. What if the total number of toys they had was 7,000? I don't know, they're living in some mansion with 7,000 toys. We could not take all that time. It would be such a waste. So we're going to come up with an algebraic way to represent their toys. First, I'm going to fix the spelling of Henry. Okay, so if Henry has 3 more than twice as many toys as George, we want to figure out who is going to be X and who's going to be the twice X and 3 more. So if Henry has 3 more than twice as many as George does, George is going to be X. He's going to have X amount of toys, because Henry's amount of toys is based on that amount. So George is going to be X, and Henry is going to have 3 more than twice as many. So this is what we did yesterday. 3 more than means I'm going to add. 3 doesn't come first because more than is a turnaround word. So when I see that more than, okay, when I see the more than, I know I'm going to be turning around here. So the 3 is going to come after the addition. And twice as many toys as George does. Well, twice as many as George does is 2 times the amount George has, and George has X. So that is my first setup. How many does Henry have? How many does George have? Based on each other. The second part is, how many do they have total? So the total number of toys they have is 48. So that means that if we take Henry's toys and we add on George's toys, and just excuse my spelling as I go through and my punctuation, that's going to equal the total number of toys. So I know that, I'm going to go down another line, 2x plus 3 plus George's toys is going to equal 48. Now I've got algebra. So I use all of this to represent Henry and George's amount of toys. I know that if I add them both up, I'm going to have a total of 48. So I add up 2x plus 3 and x, and I get 48. Now I'm going to solve. I'm going to put my like terms together. 3x plus 3 equals 48. Subtract 3 from both sides. 3x equals 45. Divide both sides by 3. X equals 15. Okay, so what the heck does that mean? What the heck is X? I go back up and I'm finding X. Well, X is George's toys. That's how many toys George has. So when I finish these word problems, I have to think about, what am I answering? Well, the question says, find the number of toys each kid has or each person has. So George has 15 toys and Henry has, how do I find that out? Well, if George is 15, that's what X is. Well, we said Henry was 2x plus 3. So I'm going to substitute 15 in for X. So I'm taking out X and putting in 15. 2 times 15 plus 3. So 2 times 15 is 30 plus 3. Henry has 33 toys. All right, good. Yay, hopefully. Number 2, a rectangle. The length of a rectangle is 1 more than 4 times the width. If the perimeter of the rectangle is 102, find the dimensions of the rectangle. So I could draw a rectangle, but I don't really know how to draw on here. Oh, I never used this to draw a rectangle. Let me see if I can figure it out because I don't want to stop my video. Yeah, forget it. Forget it. Sorry, it's going to take too much time and I don't want to waste your time. Hopefully you're fast forwarding over this little part. This is the intermission of the show. Just kidding. Okay, so if I were at the board, I would be drawing a rectangle so I could show you the lengths of the rectangle, but I don't. So we're going to talk about the two sides and think about what a rectangle looks like. So I have a length, I have a width, okay, and then it closes at the top. So these are the two unknowns I have, length and width. So let's see how one is based on the other. The length of the rectangle is 1 more than 4 times the width. The thing that comes last in that sentence, so the length of a rectangle is 1 more than 4 times the width. That thing that comes last, the width, that's going to be my X because the length is based on it. So the length is 1 more than 4 times the width. The width is X. And then how do we represent 1 more than 4 times? 1 more than 4 times the width. More than is a turnaround word. So we should have 4x plus 1. So there's my length, there's my width. Now, I don't just add the length and width together. They tell me something about the perimeter. With a perimeter, I'm going to have, the length plus another length, plus a width, and another width, right? Think about a rectangle. I have a bottom and a top, 2 lengths, 2 widths. So I can't just have length plus width. Okay, so I'm going to have 4x plus 1 plus 4x plus 1 plus x. That's what's going to equal 102. Okay, a length and another length, a width and another width. Another way you could do that if you wanted to, some people like the formula, if you remember from whenever, 2w plus 2l equals the perimeter. That's another way to talk about perimeter. We could say we're going to have 2 of the widths plus 2 of the lengths equals the perimeter, equals 102. So either way is fine. You will have the same thing in the next step, whether you want to multiply the width by 2 and the length by 2, that's fine. Just remember that length is an expression. That's not just one term. That 2 needs to get distributed. For right now, I'll leave us probably with this one. Oops. Okay, and I'll go down to this step. So now I'm going to put my x's together. I'm going to have 10 x's. And I'm going to have 2 as my whole number equaling 102. Subtract 2 from both sides, and 10x will equal 100. Divide both sides by 10, and x will equal 10. Okay, if I go do the math over here this other way, you'll get the same thing. Now answer the question. Find the dimensions of the rectangle. So we're going to say the width is 10, because the width is x. So the width is 10 centimeters. And the length is, go put 10 back in here, 4 times 10 plus 1, 41 centimeters. Okay, that's an answer. Your answer is not just 10. Your answer is not just like 10 and 41. Your answer is a sentence. The width is 10 centimeters and the length is 41 centimeters. Okay, number 3. This one's worded weird, but the math isn't that bad. A wooden board, 53 meters long, is cut into 3 pieces. The medium piece is twice as long as the shortest piece, and the longest piece is 8 meters longer than twice the medium piece. Find the length of the 3 pieces. What this is saying is I have a 53 meter long board, so I only have to think about it like it's 53 meters long, cut into 3 pieces. Boom, boom, boom. This is not an area or perimeter problem. It's just a length cut into 3 pieces. So I'm going to have a short piece. I'm going to have a medium piece. And I'm going to have the longest piece. Okay, so those are the 3 things I'm looking at, the shortest, the medium, and the longest. So a wooden board for 53 meters long, blah, blah. The medium is twice as long as the shortest. So what's x going to be? I think if you start by figuring out what x is, everything else falls into place. So if the medium is twice as long as the shortest is going to be x. The medium is twice as long as x. And the longest piece is 8 meters longer than twice the medium. Okay, so the longest is 8 meters longer than or more than twice the medium. So 2 times the medium plus 8. See how this did not go back to x. The medium was twice the shortest, so the medium was already 2x. Now the longest is 2 times the medium plus another 8. Okay, those 3 things together are going to make up this wooden board. So we're going to have the shortest piece plus the medium piece, plus the longest piece. And they're all going to add up to 53. That's my equation. So let me put all that together. So I'm going to have x plus 2x plus 4x plus 8. So 4, 5, 6, so 7x plus 8 equals 53. Subtract 8 from both sides. 7x equals 45. Ooh, this one's not going to work out, is it? Gross. X is going to equal 45 over 7. Did I mess something up? 1, 2, 3, 4, 5, 6, 7 plus 8. 53 minus 8 is 45. Nope, it's just gross. So 45 over 7, which since we're doing a real world problem here, it would be a whole lot easier if that was at least an improper or a mixed fraction. So 45 over 7, I have my calculator here. Let's just see. Do I get, nope, I get a really long gross decimal. So I'm going to say this is 6 3/7. Oh, I'm so sorry. I did not want this problem to work out so disgustingly. Well, they want to know how long each piece is. So the short piece is 6 3/7 meters. The medium piece is 2 times that. I'm not filling that out. 2 times that, and then the longest piece is 2 times that plus 8. Blah, blah, blah. We're not doing that part. Bleh. I don't want to. You get the idea. Okay, now we have a last kind that you'll see, which isn't real world at all. It's just based on like 2 numbers and how they connect to each other. So I've just says one number is 3 less than 3 times another. If the sum of 2 numbers is 41, find the numbers. So it's like, wait, do I have length and width? No. Do I have George's toys and Henry's toys? No. I just have one number and I have the other number. That's all that I've got. So I don't always have, real world example. I'm just talking about 2 numbers. So one number is 3 less than 3 times another. So I'll say that other number is X. And it says one number is 3 less than 3 times another. So 3x minus 3. It's not pretty, but that's the setup of that. The sum of the 2 numbers is 41. So 3x minus 3 plus x equals 41. There's my algebraic equation. 4x minus 3 equals 41. Add 3, 4x equals 44. X equals 11. How do we answer this? Let's just find the numbers. The 2 numbers are 11 and, so one of them is x, one of them is 3 times x minus 3. So 33 minus 3, 30. All right, last one. The sum of 3 numbers is 35. So now I'm going to have 3 numbers. I'm going to have the smallest, if when you go through and read it. I'm going to have the middle and the largest. Come on, catch up to me. There we go. Okay, the sum of 3 numbers is 35. The largest number is 1 less than twice the smallest. So right here in this first part, I'm finding out what they want x to be. So if the largest number is 1 less than twice the smallest is going to be our x. The largest is 1 less than twice the smallest, so 2x minus 1. And the middle number is 3 times the smallest. There we go. Let's sum it up. X plus 3x plus 2x minus 1 adds up to 35. Don't you hate when you're going faster than your computer can keep up? Put it together, 1, 2, 3, 4, 5, 6. 6x minus 1 equals 35. How can you be so slow? I'm talking to the computer. X equals 6. So the smallest number is 6. The middle number is 18. I know that none of this is typing because my computer will not cooperate with me. Well, it's a good thing it's the last problem because I don't know if it'll ever catch up or if it's just going to glitch out. Oh, there we go. And the largest number is 12 minus 1, 11. Okay, so the smallest is 6, the middle is 18, the largest is 11. Oh, that didn't work out at all, did it? Oh my gosh, isn't that weird? Oh, that's a weird problem that didn't really work. I had made this one up earlier, but I didn't check it. Look, it's weird. The larger number is smaller than the middle. That means the whole thing went kind of kablooey and didn't work out, but the process would still be the same. Whoops. Okay, there's your lesson, and enjoy and reach out if you have questions. And now go do the homework. Check your answer. Probably while it stops. Seriously, won't